Yes. Okay, starter. Let's try it.
5 squared, that's 25.
Yeah.
11 squared, that's 110, I think.
121.
That's it. Oh man. 5 squared is 25, and 6 squared, which is 36. That's. Hold on. Hold on. 61, 40. Then D, that's 5 plus 6, that's 11 squared, which is 121 again.
Yes. And so the purpose of that was to show that 5 squared plus 6 squared isn't the same as 5 plus 6 squared. Okay. E.
6.
Yeah. And F.
13 squared. 13 squared, that's.
So that's 169.
13 squared, yeah, 169.
12 squared.
144.
Okay. So what do you get there?
15.
Close.
14. No. 24. No, 25.
Yeah. And so what is that?
5.
Yeah. So this one, okay, let's do C and D.
This 6 squared, that's 36. Take away 5 squared is 25. That's 11. Square root of 11 is 1.
So it's just the square root of 11.
Okay.
So that's surd form. That means square root form. And
Yeah.
how about D?
B squared, 369. That's. Yeah, 3 squared is 9. 7 squared, which is. Bless you, Hawks. 7. 7 squared is. 49. So 9 and 49 is 58.
Yes. And so if this was a non-calculator paper, those would be your two answers. If it was a calculator paper, you could do that stuff in your calculator, or you could just do the last bit, square root 11, and then press SD. What is that, to 3 sig fig?
Is it 3.31?
It's closer to round up.
3.3?
To 3 sig fig.
I don't know what that means.
Three digits.
3.31.
So that would be if it rounded down.
3.316.
3.32. It's closer because the number after the 1 is 6. If it's 5 or more, you round up.
Oh, okay.
So
okay.
It's closer to 3.32.
Yeah, I get what you mean now.
roughly 3.32. If one says 3 sig fig or 1 decimal place, it's a calculator question. If it says third form, it's a non-calculator question.
Yeah.
Okay, how about this one?
B, A, C, and F.
Yep. And F is a special one. It's also isosceles. 2 angles the same. Okay, let's try this one.
C squared equals A squared plus B squared. Wouldn't that be? Well, A equals 3, so that's 3 squared. B squared is 9. B is 4, 4 squared. 16. 9 is 25. C squared is 25.
Well done. And so C.
Seven.
How did you get 7?
Just took away the squared from all of them.
So C squared is 25. How do you go from having C squared to just C?
I don't know.
What's the opposite of squared?
Cubed.
Square root.
Okay.
And so you square root both sides. What do you get?
What's our square root 3 and square root 4?
No, just square root 25.
Okay. 5.
Yeah. What is 5 squared?
25.
Yeah, so they're the opposites of each other. 5 squared gives you 25, so C is 5. And the way you calculate it is square root. Okay, let's try these ones. Stay on the top left.
For the other side, how do I find the missing value?
You just have to find the area. You don't need to find the other side.
14.
The area of a triangle. Do you remember how to do it?
No.
Half times base times height. So it's a half times, what's the base?
10.
And height?
4.
And so, what is the answer? The area.
How do I times it by a half? I can do the first 10 times 4, that's 40. Would it be 60?
Times a half is the same as divide by 2. You just half it.
No, 20.
Yeah. So the area is 20. Okay, and the one on the right?
Because I'm missing 2 values, do I have to do like 2 halves or?
Yeah, it's just a square. How do you get its area?
Half times base times height.
So that's for a triangle. And the square is like double a triangle, or like you said, there's 2 of them. And so you don't have to half it, it's just base times height.
7 times 7, that's 49.
Well done. C, expand these brackets.
X plus 2, X plus 3, I'm not sure if,
So you do it FOIL, first, outside, inside, last. So the first two is x times x. What is that?
X squared, no,
Yeah, x squared. The outside two are x and 3, x times 3.
3x or x3,
Inside two, 2 times x.
2x,
And last two, 2 times 3.
Six.
Yes, that is 6. And what is 3x plus 2x?
5x.
And so you can simplify that just a little bit. And the last one.
What am I finding my total length of?
The black and red lines. So the total length.
7.5.
That's all there is to it. 7.5. Okay, so why did we do that? It's because it helps for Pythagoras. So you have this triangle here. Height is A, base is B, hypotenuse is C, and you have 4 of them. So you have one there, the yellow, basically the 4 yellow ones, and you have a white square in the middle. What would be an expression for the area of the white square? How do you get the area of the white square?
C times C.
Yeah, I'm just going to write c squared for short. How about an expression for the area for this triangle?
A times B times C.
Close. A times B times what was it here for the triangle?
Oh, half.
A half, yeah. So I'll just write that as a half AB maybe. What would be the area for the 4 triangles on the left? So they're the same as this one. So like this times by 4, what do you get?
Just A times B, or
So that would be, if it was times 2, we want times 4. So
A squared times B squared.
what's 4 times a half?
Say that again?
4 times a half?
Yeah.
What is that?
2.
Yes. And so that is 2AB. What is an expression for the total area of everything on the left? So the white square plus the 4 triangles.
4 times a half AB.
So we got that. So these are 2AB. Yeah. The white square is c squared. And so an expression for those two, the total area on the left.
Wouldn't it be like c squared times 4 times 1/2 AB?
Yes, and because we already said the answer to that one was 2AB, we could just leave it as c squared plus 2AB. And so you see this square on the left. What is the length of the base of the total square?
AB times 4.
No, just the total length of the base. First part is A, second part is B.
AB 4 4 or something.
No, just the length of the base. So this
Oh.
bit is A, this bit is B. So if that was 3 and that was 5, what would you do to get a total?
I'm not quite sure.
It's like this one here. This is 4.5, this is 3. And so you add them to get the total. And so an expression for the base for this one here. Not sure.
No, I'm not sure.
So it just means A plus B. Basically, whatever A and B are, you add them. So like the 3.5 and 4. Okay, so we said everything on the left is the white one plus the 4 yellow triangles. So that's c squared plus 2ab. And we also know that the base is a plus b, the height is the same, a plus b. And so the total area would be a plus b times a plus b, base times height, or a plus b squared. If we were to expand that square bracket, we'd get a squared plus 2ab plus b squared. So using like first outside, inside, last. And subtract 2ab from both sides. What are you left with?
C squared equals a squared plus b squared.
Hello. And so there we've proven what's called Pythagoras. C is the hypotenuse. It's the side opposite the right angle. A and B are the other two sides, and it doesn't matter which is which. And so c squared is equal to a squared plus b squared. So you square a, you square b, and you get what? And that tells you what c squared is. And that's true for every right angled triangle. Okay, so this is 3 sig figs with a calculator paper. How do we do this? And you might not be sure.
No, I'm not sure.
So for this one, which side is C?
There's no C on there.
So I'll just call it C. It's the one that we're trying to find, and it's always opposite the right angle.
No.
And it doesn't matter which of the other two is which. So I'll just call that one A and that one B, but it doesn't matter which is which. Okay. What is A squared? What is B squared? And you can use your calculator.
A squared plus b squared. Wouldn't that just be a 2 plus b2?
So A is 1.35. So that's going to be 1.35 squared. And then how about the other one?
Plus, I have no clue.
So B squared. What is B?
3.25.
Yes. Do you have a calculator?
Yeah.
Okay, so put that in. What do you get? And you can do them separately, you can do them at the same time, whichever you find easier.
12.385.
Okay, 12.385. And so, is the length of this line that we had to find, is that 12.385 meters?
Yeah.
No, that is c squared. How do we go from c squared to c? How do we get rid of squared?
Half it.
It's not half. What's the opposite of squared?
Square root.
You square root it. Square root of 12.35. And I can do square root of answer. And they want this to 3 significant figures.
Hold on. Square root. Square root 1, 2, 3, 5. It's not working on my calculator, but
So I have it on my one. I did square the answer. So 3 significant figures they want.
3.52.
Well done. 3.52, and that looks like a much more reasonable answer. Saying that this side is 12 long might seem like it's too big compared to the other two, but 3.52 is. And another little check is that the hypotenuse, the side opposite the right angle, should always be the longest side. Yes, so in general, label the triangle. So C is the important one. C is opposite the right angle. Square A, square B, add your two answer, add the two, add the two, and then square root your answer. So square the first one, square the second one, add the two, square root your answer. Okay, that was 3.52, 3 marks. Okay, how about this one?
PHA is a right angle triangle. 4.5, 10.6. It left TI. Let's get to one decimal place. Don't I add up them 2.5 it?
You square them first.
Okay, 2.45 squared is 24.5 squared is 600.25.
0.25. Okay, go on.
Squared 112.36.
Okay, what then?
What do I do with them now?
Add the two.
Alright. $1,300 hold on. 600 and
Should be about 700, shouldn't it?
600. So my calculator's playing up a minute. Plus 712.61.
Okay, and so is this length 712.61?
No. No, you have to. Do you half it then?
Half isn't the opposite of squared.
From square root of it.
Yes, square root your answer. And they want it to 1 decimal place.
Seven, 2.61. $1.00926075.
So is that the square root of 712.61?
Nah, you've got the right one. I don't. My calculator's messing up.
Okay, 1 decimal place.
26.7.
Hold on, 26.7 centimeters. And yeah, makes sense. That one's about 24. This should be the longest one, 26.7. 26.7, 3 marks. Okay, read this, see if you can make sense of it.
No, it won't.
Why not?
Because the letterbox is 22 centimeters wide, and the envelope is 22.4.
Well, what if you were really doing this, you'd probably turn the envelope to try to get it in. And basically the diagonal is always the longest line. So
It'll work if you do it like that.
Well, it might. How long is this diagonal?
No, 27 centimeters.
No, it is using the method we just did. And I'll give you a quick way you can do it in your calculator. You know the way we always do square root of the answer at the end? So we'll just start with square root. And how do we get the how do we do Pythagoras? What's the first thing you do?
I'm not sure.
First thing we did for the previous one?
I don't remember for the life of me, Dara.
So I'll give you, I'll do it with this question first. We always square root the answer, so I'll just start with square root. And you see how the question was 24.5 squared plus 10.6 squared. So I'll just put that into the calculator, and it's a calculator question anyway. 24.5 squared plus 10.6 squared, and it's already in a square root, and so there's our answer right away. So in one go you can get the answer. I'll just paste that so you can have it. So if you just put in a square root right from the very start, one side squared plus the other side squared, all in a square root, that gives you the answer. So what would I put in my calculator for this question?
Wouldn't it be like, what's it called? The little V thing, square root, I think.
Yeah.
That's 22 times 5. 2 squared.
Yes. So it's
Squared.
yes, it's 22 plus 5, and they're both squared. 22 squared plus 5 squared, all in a square root. Let's say that's 22.56. Will it fit?
Yeah.
Yes, it'll just fit. If you put it in by its width, it will just fit. Yes, it will just fit. And actually, hang on. I might not get any marks for that, so I better just show my working out. And so your working out would be this thing here. In a square root, one thing squared, one side squared times the other side squared. Okay, any idea how we would find the length of this line? And it's a diagonal line.
So say that again, darling.
So how would we find the length of this line?
Measure it somehow.
It's a diagonal line. We have, for all of these, Pythagoras is always a method for finding the length of a diagonal line. All of these are diagonal lines. Is there any way we could use Pythagoras to find the length of this line?
Perhaps so. I still don't know.
The trick is to imagine that it's in a triangle. If this was in a triangle, what would be the base? So how many across is the base?
Perhaps so. Say that. So, I've just got a headache at the moment.
Alright. How long is the base?
5 squares long.
It goes up to 5, but it doesn't start at 0, it starts at 1.
No, 4 squares long.
That's it. What is the height?
2 squares up.
And so you have to find the diagonal, and the way you find the length of a diagonal line is Pythagoras. What do I put into my calculator for this one?
1.2 divided by 4. Or
Nope. It's just 4. That's 4 across, and that's 2 up. So it's just like any other triangle. like that. And so how would you find the x?
Four. You add 4 and 2 together.
Yep.
Man. Sorry. Keep on.
And this is the working out from the previous one.
Yeah,
It's in the calculator.
would it be 4 squared plus 2 squared in the square root?
Correct. 4 squared plus 2 squared, square rooted. And so you could write your answer as 2 root 5, or you could write your answer as, let's say, 4.47. That's it. So you can use Pythagoras to find the length of any diagonal, and the way you do that is to imagine that it's inside a triangle, and you use the base and height for that. Any questions there? Are you good? Okay. Okay, tricky one. How do we do this?
Holy crap. Sorry, Dara.
Yeah.
5.8. Wouldn't it be the square root again with 5 squared plus 8 squared?
That's it. And so they wanted to do 3 significant figures. Okay, so 5 squared plus 8 squared. So 3 significant figures.
Mm-hmm.
What is that? So 3 sig fig.
What do we do now, Dara?
3 sig fig.
9.4. 4. Would it be 9.44?
The number after the next one is lower than 5.
9.43. 433.
That's it. 9.43. 3 sig fig. 1, 2, 3. Technically, they didn't ask for the length. They asked for the circumference. Do you know how you find circumference?
I'm sure I do it, but I don't know how you do it.
Everyone forgets this one. Circumference is pi times diameter. Which line is the diameter in this?
I'm not sure what to do now.
Which line is the diameter in the circle? Do you know?
Is it O?
So it's the line that goes through O, yeah. And that is actually the line we just found. And so the circumference is pi times the diameter. And so it's just pi times our answer. And so our answer times pi. And they want this to 3 sig fig.
Mm-hmm. 9.4. 6.
That's it. That's 3 digits. That's how you're done. Any questions there?
No.
Okay. So this was exactly the same thing. Put them, square both of them, add them, put them in a square root, except you had to times your answer by pi, because that's how you get circumference, diameter times by pi. And so that's roughly equal to 29.6, and I'll write centimeters. 29.6, well, that's a 4 marker, wow. Okay, how about this one? No, actually, let me just do something else.
Okay.
Let me skip ahead. I can always come back to those. So that one there, x a half or tick, Pythagoras.
Half.
Okay.
Answer.
So these are the higher questions. How would you get a squared equals?
No. I'm not sure.
You could, well, you have a squared plus b squared. You want just a squared, and so you take away b squared.
Okay.
And so on the right side, what do you have?
A squared equals c squared.
Yeah, what else?
No.
We now also
Is
have minus b squared. So you have to do it to both sides to keep both sides equal. So a squared equals c squared minus b squared. Let me go to the higher question for this. Okay. So a squared is equal to c squared take away b squared. So if you want, so this time we're given the hypotenuse and we have to find the length of the other side, and to do that we do the square root of c squared take away b squared. And so now it's important which one is c. And so how do we do this?
So you say that again?
So for this one,
Mm-hmm.
let me. So for this one, it is c squared take away b squared.
Okay.
And then you square root it. And so what am I putting in the calculator?
C squared. I'm not sure what's the values of C and B?
So we've got 6 and 13. So which is which?
Is that the values for them?
Yeah.
Right, so it'd be 6 squared, or wouldn't it be like a square root thing?
Yeah.
6 squared.
Um,
No, square root thing meant in it is 6 squared plus 13 squared.
So for this one, because we have to find the length of the missing side, we're given the hypotenuse and we have to work in reverse. That's why we're subtracting. We have to subtract instead of add this time.
Alright. Wait, so I say that again?
So it's not a plus in between them, it's a minus in between them.
Alright, so it'd be 6 squared take away 13 squared.
So that would give you a negative number.
Do we not want that?
Well, you can't. This can't be like a negative number long.
So would it be 13 squared take away 6 squared?
That's it. So 13 is the C, because that's the one opposite the right angle, and then it doesn't matter the other two, which is which. 3 sig fig.
Say that again, sorry.
To 3 sig fig.
11.5.
Yeah. 11.5. There we go. Let me just go back to where we were. I'll see. So this one, okay. Mostly higher. Okay, I'll do a recap. Okay, Pythagoras. What is Pythagoras used for?
I'm not sure, I mean maths.
Finding the length of what?
Shapes.
No. Of a diagonal line.
Of a diagonal line.
And so diagonal lines come up all the time. You use Pythagoras for it. You just say how many across squared, how many up squared, add the two, and then square root. Maybe I'll just write it like that. So I'll just put a square root, and I'll just say base squared plus height squared. And so that's the formula for it. That gives you the length of any diagonal line. Base squared plus height squared. So we did a starter, and what we saw is that the important bit, C and D aren't the same thing. They give two different answers. So you don't add the two sides and then square. You square the two sides and then add.
Yeah.
If it says surd form, what does surd form mean?
It's still got the square root box on it.
Yeah, it's like square root form. And then if it says to 3 sig fig or to 1 decimal place or a decimal, that's a calculator question. What type of triangles is Pythagoras used for?
One's like DC and F.
AC and F?
That's it, AC and F.
Actually, you're right. What is 64 plus 28?
$98.
I think it's exactly 90. And so D must also be right angle. Yeah. Basically, Pythagoras is used for right angle triangles.
Okay.
In right angle triangles. So we practiced it. Here we did the starter. Here we proved that it's true. And by doing this, we proved that C squared, this diagonal line here, that squared is the same as A squared, B squared, and added together. And so you can do that and then square root. So we practiced this one. Square the first one, square the second one, add the two, and that's your answer. So we did that first one the long way. What would be the quick way of doing it with your calculator? And these are all calculator questions.
Wouldn't you just get the square root box
Yep.
thingy, just stick them two in,
Yeah.
but put a squared on each end, and
Yeah.
so it'd be like, then wouldn't you add it?
Yes, well done. If you want the diagonal line, you add it. If you have the diagonal line and you want one of the other two, you subtract it. And there we got 3.519, which rounds to 3.52.
Figures, wouldn't that be?
Yeah, and that's the same as the answer we got earlier. 3.52, 3.52. So that's a much quicker way. And you're getting better at it. So then we did it that quick way there with the calculator. So the first one you always do the long way. We did it for worded questions. So it's the length of any diagonal line. That's what it's used for. Here's a diagonal line. You just imagine it's in a right angled triangle. The perimeter of a circle is pi times the circumference, is pi times the diameter, and the diameter is often a diagonal line, and so it's pi times the diagonal line, and so it's pi times your answer. So same thing again, except just times it by pi. So the circumference is like the perimeter. Yeah, so just a little extra step at the end for an extra mark. So then we had these ones, just more the same. Skip that. More the same. So then this one, if you have to work in reverse, it's instead of plus, it's a minus. And just make sure you label the correct one is C, the one up at the right angle. Yes, and so this one was 13 squared take away 6 squared, because we were given the hypotenuse and we had to find one of the other two. So it's just that in reverse. And let me just check. Yes, what would you give yourself for that one? So just Pythagoras in general.
I'd still go at the half.
Okay, so that's a tricky topic. All three, at least 3 mark question for each one. How was that for you, Dan?
Tough.
Yeah, good. Anything in particular you want to do next time, or should I pick?
You can pick.
So I think Sokotoa, which is like trigonometry.
Okay.
So that's for finding